Thank you very much. Thank you very much for inviting me, for having the chance to being part here. I will put just the microphone here behind, so you can hear me, hopefully. Okay, thank you very much. And I'm going to start. I want to like to today about how to help consumers. So the title here, subtitle is Algorithm Support to help consumers navigate uncertain decision environments or information environments. And I start with a very common example that is not since the pandemic. It was quite a very prevalent everyday topic, say that people try to find some health information on the web. They do it for preparing a visit at the doctor's office. Do it afterwards. They do it while they are at the doctor's office, and sometimes instead. And what is important here, that's a very good example for an information environment that poses many challenges. And it's clear that here you see data from Germany, from insurer survey representative computer-assisted telephone interview, and you see, okay, the percentages of people who report using internet sources to inform their health decision was pre-pandemic already relatively high, also among those who are the oldest. This is here the group of 60 to 70 years. So this is, the most of you will know this from your own experience. And the question is really what is happening when they go onto the web via a smartphone or via computer, and you can imagine easily what you find. If I find things like this, and it's very difficult to assess this in terms of quality. We did we collected health pages with the help of experts and with the help of lay people, and could evaluate them with the help of experts, and could say, okay, about a minimum 85% do not support informed decisions, so this is not possible to do here a representative, exhaustive sample of the German language health information market, but you can see where the line goes, and this is in line with findings from other studies, for instance about cancer information, who show that there are violations of the rules how to present health information. So what is happening is that people find technically wrongly made information. I don't know, not talking about lies and fake news, but technically wrong made health information, so people cannot make an informed decision, so they cannot weigh the potential benefits and harms of doing something or not doing something. And yes, for sure, there's also a lot of information that has conflict of interest. You know this. So this is the problem. So, and people do not really perceive this. So the people by themselves, they're on their own. Again, the survey from Germany, the most of them here, the blue bars, are really relatively positive about how well they find or how well they get information on the web, but the picture changes the moment when it's become more relevant. If you're talking to chronically diseased people, that's the right side, then you see that there is the red bar going out, a purple bar going up, where you have 12% here. And don't ask me where the missing percentages in this study. It's not our study, but what I want to say is once it becomes more critical and people are, for instance, chronically diseased, then they learn what they do not find. They learn where they are, for instance, brought in the wrong directions. So this is something where it's not so easy to figure out whether how well the people are doing this. There's a couple of transnational assessments of health literacy, but they are very often, mostly they rely on self-report, which is also very difficult because you cannot really report very well how well you find things. So in the deepest core, you hear the comparison heads up of two different pages. So this is a typical, very common, independent, evidence-based, I would say, high-quality page in Germany, gesundheitsinformation.de, and from last month. And the other one is a very clear, problematic page, commercial, esoteric, and spreading fake news. And so these are extreme cases, and you see both of them capture a lot of attention. So these are 1 million visitors from last month. It's obviously, so the question is, so the situation improved, by the way, a lot. If I would 2 years ago, was much more worse. But you know, from literature, people have difficulty assessing the quality of information. So what can we do? One way is increase the number of better offers, to increase the number of health information that is evidenced and highest quality standards. So it's one possibility, so that the many actors, very often public money, try to build up better offers. But nevertheless, so this is an example, a collaboration from our center together with the Robert Koch Institute during the pandemic about how to inform lay people about COVID vaccination. But what's more interesting is the question, can we do something about how the people find information? Which is really challenging, because most of the people in Germany you cannot reach in institutional education settings. So you can reach some students, you can reach the pupil, but the most of the people, the consumers, you cannot reach easily. So the question is, what can be done in between educational approach in institutions and improving the offer at the market, because still there are a lot of problematic offers out there in terms of health information. So the environment in which I navigate when I try to select health information is really messed up still. So one possibility is the boosting approach, so-called by Till Grüne-Janov and Ralf Hertwig, and thanks to Ralf Hertwig to his input to all these aspects of boosting. So boosts, in contrast to nudging, boosts target competencies, but also can be helpful for immediate response. So according to Ralf Hertwig, boosts aim at domain-specific and domain-general competencies. They target human cognition or the environment or both. They preserve the agency of the individuals. That's the key thing here. The question is, can we do something about, can we help consumers reduce uncertainty when they face this vast mass of, for instance, health information? This is one example I use today, so you can transfer this easily to other information search contexts. And boosts are transparent to the individual. That's important also, so they can understand why it helps them. So I condense our boosting approach in this picture, saying separating the wheat from the chaff, and I'm pretty sure that I used the wrong plant, but but it's about separating the wheat from the chaff. So that's the issue here. So when I show you this picture, I showed it you already, but when I show you this picture, you immediately know whether this guides you in your decisions. You immediately you take a couple of seconds, and this is even more the case for experts on evidence-based health information. So there are experts out there who worked for decades on this issue. So they use certain cues. There's certain signals that they allow them in a couple of seconds to make such kind of decisions, to switch to other sources or references. And the question is whether can we make use of this. So first of all, boosts aim to equip consumers with competencies. And the idea is to make this possible by letting them practice a kind of assisted uncertainty reduction. So when an expert is facing the problem, he or she knows where are the cues and can reduce uncertainty relatively quickly in the choice set, for instance, by disregarding such kind of offers very quickly. And the question is, can we lend this, or can we give this to lay people as well? So what do we have to do is here develop kind of cue-based boost based on critical indicators, then provide a consumer. And the idea is that the consumer then uses it, and while using it, learns about this. The question is really how we make that the consumer, the layperson, can mimic the expert. So we know about the benefits also, or the value of simple decision-making strategies when it comes to problems of uncertainty. When we have not enough reliable evidence, when it's too much complexity, when there's a dynamic decision situation where you need robust strategies. There's a lot of research by Gurens and colleagues. And this success in making successful decisions under uncertainty is also highly, very strictly based on experience, which is due to learning opportunities. So getting feedback over years. The question is how we could make use of this experience. So I present as our boost here one example, the fast and frugal decision trees. So which is a class of models, which is a kind of formalization of multiple heuristics. So you combine different heuristic strategies into one. And the key is here that it, as other heuristics too, it ignores information. So it's about ignoring potential predictors that help normally perhaps to classify. It is a type of decision tree, a specific type of decision models. Decision trees that do not branch out. It's more like a chain. Like a chain. So always one question, one check, one exit or continue. Exit or continue. That's what's happening. That's the structure of those trees. So the order is clear. You cannot change this, and it's non-compensatory. Once you are exit, you cannot return. So, and this type of model was shown in different contexts to allow for highly accurate classification. So it can, under certain conditions, compete with more complex models. Shown in medicine, anesthesia, for instance, or finance and military decision making. So it is a candidate for a boost for consumers, particularly not only because of the possibility of being potentially, hopefully, accurate, but particularly because of being an interpretable model also. Because what we want is something that is quickly applicable and that's communicable, what you can use to teach others. In health sciences, you would form it like it is like a type of educative user instruction. So this is the fast and frugal tree, and this is the thing I'm talking about the next minutes. So here's an example of classification accuracy of one of the first fast and frugal trees developed, where you can see here the false positive rate on the x-axis and the y-axis, the sensitivity, the possibility to recognize patients who come to the emergency department and should go to the intensive care unit. So detection of patients who should go to the intensive care unit. And as you can see here, then it is only to give you an example. So a fast and frugal tree can help to detect over the standard physicians in a clinical study, to detect more of them who need to go to the intensive care unit. So detect them, help detect them, and reduce the false positive rate. So assigning people falsely to the intensive care unit can reduce this. So it's only an example. Say there's a lot of papers and studies out there try to find ways how this can be used in different contexts, and we want to use it for the consumer problems. When consumers search digital environments, for instance, information environments, that can be health information as in my example, but also, for instance, financial investment options. So the question is here really how to do this, because there are not the data available. As I said, it's very difficult already to assess what is out there in the German health information market. What do other people find on the computer? You have no idea what they find. So this is really difficult. So it comes into play that you do not find in the literature data you would like to have. And it comes to central role, which is quite consequential, because I said we would like to mimic the expert. We would like to give the consumer the possibility to check a bit, to screen at least, a bit like an expert. So what is the first challenge? Candidate features, cues, indicators, things that could help me to identify whether I have a problem in front of me or not. So we have a lot of literature on this already. So there's happened a lot in the health sciences. So we have international discerned standards. We have a medical guideline on evidence-based health information in Germany. And you have a collection of features of indicators that help, for instance, experts to identify health information that helps to make an informed decision, and or to exclude, for instance, those who do not. The second one is, for sure, is how to collect cases. For sure, this is something we tried now here with expert sampling, where we try to cover all those pages experts know in German language, at least, to collect all those things. Additionally, copy a search strategy that had others in a study before. And also we asked lay people to find things and try to what they arrived at, because lay people find totally different things. Lay people find things that are very difficult to classify. Lay people find information about health that are not health information that help you with decisions. So they find things that you would neither classify as fake news or something like this, but they do not support decisions. So these are, you can find physiological information, for instance, that do not guide the decision, that neither guide the decision of the doctor nor of the patient. So it's very difficult to get a kind of basis on which way you can act, particularly once it comes to using experts, because you cannot confront experts with too many cases. You have to make a limit. So but before we talk about this, let us talk briefly about the classification goal, what you want to achieve, and what's the validation criterion. So what you would like to achieve. The patient sits on the computer or on a smartphone, and ideally the patient would say, okay, I cannot make an informed decision based on this, what you're giving me here. And this is the decision then. So I cannot make an informed decision. So what is the classification goal? So we have a law in Germany for improvement of the rights of the patients, which really has the wording in it saying, okay, informed decisions, so the possibility to weigh the potential benefits and harms of having or not having a treatment or preventive measure should be possible for the layperson. Ideally in collaboration with the doctor as shared decision making, but this is not happening regularly when the people sit at home or in a train when they read health information there. So, but that's the classification goal. So the consumers, once equipped with the tool, the boost, could select between those pieces that enable informed decisions, those which do not. So this is the idea. Okay. The validation criterion is the hardest part here, saying, okay, how do you recognize that the tool is doing this? The ideal version would be that you take all those cases that you found, all those instances of health information, and test them, and test all of them. Test with lay people and see whether people have informed intentions or not when you present them with this what you found. But in the case of more than 100, in the case of 700 of those types of information, this is a challenge that you could not easily address experimentally. So it's also not so super easy to do this one, but it's possible, either possible, because there's a strong community also on experts in developing health information from research, but also academia, but also from practitioners. And as you see here, we did this. We surveyed 42 experts from different approaches to health information, and let them rate each of them. So we not everybody, every 700, we had 3 experts per health information, and using then median as a kind of consensus measure, a robust measure. And they had just rate the question whether this enables or not. But we did it 4 types, as you see, definitely not, probably not, probably, that's definitely. So, and this should be then the benchmark to show, okay, the tool can do what you want. But what comes before is that you have the kind of the cases and you have the experts, but you need the features put on those cases, but nobody coded this for you. So that's again a whole enterprise that you start out with 66 potential candidate queues and 700 cases. You cannot do it this way. So you have to work adaptively and try to find a way how to understand the properties of health information that are available on the web. And what you learn such an thoughtful approach is how well the whole thing could function if of your model, how well this could work. Because this coding reveals, okay, these type of 65 potential indicators that are available, how many of them lay people can check? There are very predictive features, but you have to study first something before you can check this queue, this highly predictive queue. So you do not have what I wrote here below, you do not develop the most accurate decision tree, you develop the most accurate tree that the users can apply. And this process of coding through all these different types of pages let you learn whether it is possible that lay people can do this. You learn whether it's reliably codable, that you can say, okay, this type of indicator holds. And particularly saying economically, okay, this is not so super relevant here as long as there are not paywalls in between involved. But objective is the key thing. What you want in the end is once you have this decision support tool, this boost, and give it to lay people, that 10 people come to the same conclusion when checking a queue. They should come to the same one. It's very difficult to formulate, to label the way that it happens. So the first question then is whether this fast and frugal tree as the boost works in terms of accuracy or efficacy. Well, this is the first thing. So what you can do is model the whole thing on this data set that you build up on your own. On the cases, the observations, the features, and the expert judgments. And you can try to mimic the expert judgment. This is done by the help of the very helpful R package by Nathaniel Phillips that allows you to do something what you also could do by hand, by the way. It's possible to construct fast and frugal trees with, for instance, according to the ordering of posterior probabilities of the features. You can do it by hand. But there are more complex algorithms available for develop such type of algorithms. And what you see here is that you get a kind of result and can test then the performance. So, and you see here that there's still a lot of false alarms involved or misses. What I can say in the end, in terms of classification accuracy, is that you can find out 9 out of 10 problematic cases, but you still have false positives in ruling out 4 out of 10 those you would like to have included. So it's very difficult at the moment to go beyond this. But this is then the next step already, saying, okay, implementation. So we're talking about not only efficacy, the question is what happens if you give it to the people. And this brings up the new hurdle, or again the hurdle, as I said, how you communicate about the boost and within the boost. About the boost is clear. If you do qualitative studies, the people see this thing and say, okay, this is way too few. You cannot check only 4 features. That does not work. I do not trust that thing. So simple approaches have a difficulty of legitimacy. I'm not sure whether it's the right word. No, legitimacy is not the right word. But saying if it's more complex, it's easier. You have more some kind of opening of the people. They appreciate sometimes to a certain extent complexity. But why should I use it? Awareness of the problem. That's always an issue. Clear. The half of the way is done if you make people aware of the problem. But these are things you have to drive in the communication around, but also within. So it is about, for instance, you cannot approve. You are never perfect. You cannot say it. You cannot develop the tool and say, okay, it will definitely help you to make an informed decision. This is not possible, as you have, as I said, a limited classification accuracy in the end. So you have to be very sensible with the phrasing, or careful with the phrasing. So warning, would you say, okay, a warning, you cannot make an informed decision. What seems plausible, and given my concept here, really produces some reaction in participants. So they think about, oh, did I do something wrong? So this is not in the paper and pencil version, okay, but we did this put this in an app. When it happens in an app and there's a red thing saying warning, you cannot make an informed decision, then many participants think in their own terms whether they made a fault. So whether they made an error. So this you have to consider then when implementing such things too. So this is what you have to address first, and then you can test, okay, can a fast and frugal tree help actually? So this is what's more interesting, the question when you give it to the people. Okay, and we did an experiment. As psychologists, we are doing this very often here in a lab study between subjects designed. So half received an assist and half of them received nothing. So, and do participants more likely select than in the end evidence-based health information? That's the question. And we prompted different types of web searches. So participants came to the lab and had the task to find things on the web. Please search. But we gave 3 different conditions saying, okay, open search, we set a goal-driven where we had a scenario saying, okay, you have to find a solution, hop or top. And the third one is a balanced scenario, what we intentionally varied the way that the friend would like to understand the potential benefits and harms. So we are very going into the direction of planting the idea that you could weigh the benefits and harms. So, and they had 3 different types of indication in the scenarios. Also, the medical conditions they should search on were antibiotics and the screening and vaccination, mumps, measles, rubella. And yeah, we measured in the first place, or the primary outcome for us was then for sure the quality of those things that they found. That's what was interesting to us. So we took all the whole things they found and gave it to the experts. And then also whether they somewhat changed their search, whether they generalized to check or try to check other cues that are helpful as well, that we knew not included, and also whether they memorized, and as I said, they learned something, whether they memorized the given cues at least. Yeah, the improved, so the having a fast and frugal tree, I have to say, not exactly the same health trees, was a bit different. Having the tree improved the findings. The ratings improved only slightly from 2.7 to 2.4, where 1 is the best on a scale from 1 to 4. So it is, I would say, a small to medium effect, cones are. But the search did not generalize. So the search for cues did not generalize. So they did not consider then cues, or did not report afterwards that they consider cues that are relevant to that we did not include in the model. So they were really relying on the given cues. And they memorized the cues given. That was positive. So they had a 50% chance rate and 77% they correctly recognized. What has something to do with that the tree is one works with the tree in a lexicographic order. This means that if you are following the strict scheme every time, you do not very often do not reach the last cues. So you cannot more likely not learn the cues that are below the line, because less often you arrive there. So that's the idea now. He's saying, okay, we can give it to people and have at least a small effect when they search information. So let me just give me a brief summary. So the question was how to help consumers reduce uncertainty given information overload, actually, because there are too many offers on the place. I used the example of health information market. So, but as you know, you could imagine a lot of other application cases, and actually we did this for other contexts, consumer contexts as well. So the fast and frugal trees as a model class are the tool to formalize experience. There are different ways to build them. I showed one way. There are purely data-driven approaches. If you have the data sets available, statistical approaches, that's possible. But most often in such of type of application questions, you don't have the data. But you have also the choice to have a even more expert-driven approach. So what we did later was, for instance, working on the feature validities of the indicators directly in workshop formats. We were not first doing this, it was done before, but this is something that you also can consider if you have a problem, a decision in an organization that's made very often and that's under uncertainty, and the organization does not know how to formalize this or how to teach this to new beginning people. Then you have the chance to sit down with the experts from this organization or from this field and invite them to sit down 1 to 2 days and work on the features and work on the indicators and their validities and then by hand build up such a tree. That's possible. So it's an approach I showed you to translate the experience into a kind of decision-making tool, and which is a boost because it helps people when they use it. This is an example where people indeed, at least certain extent, selected rather information that are evidence-based and rejected others. And yeah, it also prompts all reflections and discussions. So people, it also has something to do with creating awareness, as many other tools do it too. What needs to be considered in the end, nevertheless, is that you have a lot of potential implementation side effects when you bring such a thing to life. More precisely, you have the one thing, you have to consider that the market changes always. So there is a need for update always. But also you have to consider it's an interpretable, transparent model. So in some questions, there are a lot of actors who are interested in gaming this model, in trying to find strategies. And if they see, formally different. If you include indicators that are highly predictive, but are not causally related to your outcome, so if they are only superficial cues, then you have the problem that people can try to game your tool, and so those who offer health information try to then just to address your tree, but not improve the quality. So this is one thing you have to consider when building these things, and you have norm building, as always, when you introduce such type of decision tools, that others who not use the tool also learn something about what could be valid predictors, what is the criterion you choose, why is it relevant that experts think that you have to make an informed decision. One could have other benchmarks in mind. And also a very often underestimated problem is, and I'm really done, the time is up, is once you have, imagine that you have a successful algorithm that supports decisions, and you bring it into the system, and everybody uses this, then perhaps the people make less error in classification, but they more often make the same error. That could create new susceptibilities of the system. So this is something you have in mind in such kind of decision tools as well. So in the end, my last statement about this is, once the consumer information comes to or reached a certain limit in their effectiveness, it is really now the question how to educate people more, consumers specifically, that you do not reach school or universities, to how to train them in the skills to reduce uncertainty. So and this is one way, and if you want to do is, if an organization who is working or which is working in consumer education wants to do this, they have given these difficulties to have to establish in the first place a kind of technological pipeline, an expert pipeline, on which basis they regularly can do such a thing. That's something we did not solve so far. Okay, thank you very much.